Today's topic is inverse trigonometric ratios, Unit 3, Day 12. The objective is that you will be able to determine the angle measure of right triangles using inverse trig ratios. Now, inverse trig ratios are really useful because they allow us to determine the angle measure when we're given two sides of a right triangle. So previously, when we were doing trig ratios, regular trig ratios, we had an angle measure and one side, and that allowed us to determine the other two sides of the triangle. But because these ratios stay constant, if you know two sides of a right triangle, then you're also able to use the ratio to determine theta, or the angle measure. All right. If you look on your calculators, there's sine, cosine, and tangent, but right above them, if you push that second button, you'll see a sine with a -1 in the exponent, cosine with a -1, and a tangent with a -1. And that exponent -1 is our inverse cosine, or is our inverse sine. All right, so let's take a look at our first example to see how we can use our inverse trig ratios. It says determine the measure of angle F given the triangle below. So we know that F here is theta. Then we go through that same process of labeling opposite, adjacent, and hypotenuse. Now we're looking at which sides are we given information about. It is our opposite and our adjacent, which means we should be using tangent for our equation. So the tangent of theta equals opposite over adjacent, and I'll fill those in. We don't know theta, but we do know the opposite, and we do know the adjacent. Now from here, we're going to be solving for theta. And this part's a little bit weird, but what we can essentially do is divide by tangent. And divide by tangent, leaving us theta equals 1 over tangent times 4 over 6. And if you remember our exponent rules, 1 over tangent is actually the same as our tangent to the -1 exponent, 4 over 6. At this point, we can plug it into our calculator. Inverse tangent, 4 over 6, theta ends up equaling 33.7 degrees. So what that tells us is here, theta is 33.7 degrees when you have a right triangle with the opposite of 4 feet and an adjacent of 6 feet. So go through that same process and try student example number 1 below. Now our second example is just a bit of a story problem. It says determine the angle of depression given the scenario below. The picture tells us that the angle of depression, which is always from the horizontal and then that angle going down, is actually the same as our angle of elevation, which is, again, from the horizontal going up. So if we find that angle of elevation, it will be the same as our angle of depression. So then if I have my theta here, I know that 50 is my opposite, 30 is my adjacent, and then this is my hypotenuse. Again, I'm given information about opposite and adjacent, which is tangent of theta, which is opposite over adjacent. Tangent theta equals 50 over 30. And then we're going through that process, divide by tangent, divide by tangent. Theta equals inverse tangent, 50 over 30. And that leaves us with 59.0 degrees. And that means our angle of elevation and our angle of depression here is 59.0 degrees. So try your student example number 2 below. Remember that when you're writing your summary, it should be 3 to 5 sentences, that you're using the objective and academic vocabulary. Thanks for listening, guys.